So we all have a brain. It is what helps us communicate with others, it keeps us alive, it keeps us functioning, it helps us control our emotions, and pretty much just be a person. Hi, my name is Sophia Osmera, and I will be talking about chronic traumatic encephalopathy, which is also known as CTE. Before I get into the human brain, I would like to talk about the woodpecker. The woodpecker spends its entire life slamming its head against a tree. It can slam its head against the tree about 20 times per second, with the force of what it would be like to hit the ground after jumping off a 12-story building. This is kind of crazy, and I found out that woodpeckers have what I like to call a brain tongue. Their tongue connects at the front of their skull and then wraps around their brain inside their skull and kind of just holds their brain in place while they slam their head around. Humans do not have this. Our brain kind of just floats inside our skull in this just jelly liquid stuff. So when we move our head back and forth, our brain just kind of sloshes around inside. And if we hit our head too aggressively or come to an abrupt stop after running, or you hit a wall or crash your car, your brain will follow that momentum and smack your skull. This causes brain damage and it likely causes a concussion as well. So concussions can lead to CTE. And so in my research, I wanted to know, what is chronic traumatic encephalopathy, and is a living diagnosis possible? So what is CTE? CTE is a progressive neurodegenerative disease that commonly occurs after multiple head injuries. And it's not fun. It can cause a lot of issues, and no one likes it. I'm going to explain CTE in two different ways. I'm going to explain it first in a much simpler metaphorical kind of sense, and then I'm going to go into a lot more of the medical, intense, kind of really confusing terms. So this is what I call the bridge metaphor. Imagine you have a bridge, and a big truck drives across it. This can cause damage to the bridge. If the bridge becomes damaged, a builder will come, and he'll try to fix the bridge. If he fixes it properly before more trucks drive across, then great, the bridge is back to normal and it can be used properly again. However, if another truck drives across before it is fully fixed, this causes more damage, and more builders then need to come and fix it. However, after the second impact, the more builders will come, and their extra weight will then cause more damage, which then pulls in more builders and then causes more damage until it all kind of just collapses into a big pile of messy junks, or whatever. So this is pretty much what happens if you get a concussion and it doesn't heal properly, and then you get another one very soon after. So in a more medical sense, you have neurons in your head, and in between these neurons you have microtubules that then transfer the information back and forth. On these microtubules, you have tau proteins. They stabilize these pathways and help it transfer the information properly. However, when you get a concussion or you hit your head, these tau proteins detach from this pathway and become hyperphosphorylated. This hyperphosphorylation then pretty much lets the immune system know that there is damage that needs to be fixed. The immune system then comes and releases inflammatory markers, which are actually kind of good in a sense. They help protect the damaged cells and help it repair and clean up any debris or anything that's not really great. However, if it heals properly right here, then it goes back to normal and it's great. However, if it does not heal and is still unresolved and the inflammation is still there and you get another head injury, then more tau detaches and becomes more hyperphosphorylated, which then causes more immune responses. This is not good, because if there's too much of an immune response, it becomes primed. This makes your brain pretty much super sensitive to any damage, and this brain and immune system can stay primed for up to 17 years. So for 17 years, your brain is very sensitive and can become easily damaged and get really bad. So the immune response then starts causing damage when it becomes hyperactivated, which then causes more tau to break off, and then more immune responses, and then more tau to break off, which is not good in any senses. So when too much tau is broken off, they become these little tiny tangles, which then start breaking apart your neurons and disrupting any communication, and it basically becomes irreversible damage. So there are 4 stages of CTE, which are characterized by the buildup and the progression of tau in your brain. In stage 1, it's not very bad. Your brain is still pretty much functioning normally, and the tau is just in small little places, and individuals with it might experience some headaches, a bit of like anxiety here and there, but it's not super serious. However, due to CTE being a progressive disease, it will continue getting worse over time. This can take up to decades for the next stage, but it still will happen because there's no way to stop it at this time. So in stage 2, also these are these little like buildup of brown stuff is the tau that's accumulating. In stage 2, it'll start spreading. It starts in the frontal cortex, and it'll start spreading into the parietal lobes and the hippocampus. This is not good, and it'll start messing with your emotions, and you can become super depressed. Some people become suicidal. They can't really control how they're feeling, and they can become violent and not really happy. However, if CTE reaches stage 3 or 4, it is very bad. This is when you can start noticing changes in the brain. This is brain atrophy, where it becomes kind of like dead on the outside due to the cell damage, and it starts shrinking and falling in on itself. This is really bad, and in stage 3, people become paranoid. They might experience like schizophrenic type symptoms, super depressed, not happy, they can't control their emotions, they'll basically just have like random outbursts and kind of fall apart. In stage 4, people become pretty much unable to live on their own. They are super paranoid, they'll lose all muscle control, they won't be able to walk or speak properly, and they will be basically falling apart. So CTE can't be diagnosed while someone's alive, which is a big issue. So over here, this is a normal brain. This is a brain with CTE. But you can't realize it has CTE unless you cut their skull open, take their brain out, and inspect it under a microscope, which you can't really do when someone's alive. So people who have CTE will spend their entire life suffering from a disease that they can't find or don't have answers to, which is not fun at all. So I would like to talk about a few people who have experienced CTE. Aaron Hernandez was a footballer and played in the New England Patriots, and he got a lot of head injuries over his time in the sport. He eventually became super aggressive and didn't really know how to function on his own. And he eventually shot his wife's sister's fiance and was sent to jail. And while he was being prosecuted for first-degree murder, he hung himself in his cell and committed suicide. His brain was donated to science, and they found that he had stage 3 CTE. And Dr. Ann McKee, who was the one who dissected his brain, said that his brain was appeared the same as an 80-year-old with severe Alzheimer's disease, which is not really good. Here you can see that Hernandez's brain had a ventricle enlargement, which is considered part of the atrophy, and the outside is kind of falling in on itself and collapsing. Not good. Another individual is Chris Benoit. Chris Benoit was known also as the Canadian Crippler. He was a WWE wrestler and took many shots to the head with chairs and just other people while he participated in this sport. He got a lot of brain damage as well, and one day he ended up shooting his 7-year-old son and his wife and then hung himself next to them. Later on, when the media found out, people were completely shocked because they said that he had always been a super kind person who only cared about others and always put other people and his family first. However, they ended up discovering a journal from him that described the past few years of his life, and he had very descriptively described himself kind of falling into a dark hole of depression and symptoms that he didn't understand, and he felt like he was losing who he was. So both of these people had been participating in these sports for many, many years, and they were older and on a very high level. However, this individual, Wyatt Bramwell, was 18 when he shot himself in his car. He had only ever played tackle football on his high school team and then played football, like flag football, when he was a kid. However, in high school, he became super paranoid and depressed and started feeling like he may have CTE. He had heard a lot about it and was suspicious that he may have contracted it somehow. So right before he ended up committing suicide, he recorded a video that he sent to his parents that was then later released, and I watched it, and it's super sad. But he pretty much says that he felt like he had become someone he wasn't, and that the last 4 years had been a living hell inside of his head. And since he had heard about CTE and that there was no way to stop it, he thought that he was better off dead than having to suffer from a disease that couldn't be cured. So CTE we need to be able to diagnose CTE while someone's alive so that we can fully understand the progression of it. Due to only being able to fully understand it when someone's dead, we don't understand really how it progresses and what causes it specifically. So being able to fully understand it, it can also give people answers to why they're feeling a certain way, and it can also help catch it early on before it gets super severe, so maybe they can even be in therapy or get on certain medications that may help. So even though they don't have a certain way to detect it definitively, they are slowly coming up with certain things to kind of help be like, oh, maybe they do have CTE, or they are suffering from this disease or whatnot. One of which is the test criteria. The test criteria is a behavioral assessment that looks at someone's history of potential brain damage or a possibility of repeated hits to the head, which is what causes CTE. It also then looks at their clinical symptoms and behavioral and emotional state at this time. It also compares it to how they were about 10, 15 years ago to see if it has developed in a way that they think is similar to CTE. They also look at someone's memory and if they may be showing signs of Alzheimer's or dementia at an age that's 30, where someone shouldn't be having these symptoms at such a young age. Even though it doesn't tell them if they have CTE or not, it does give them sort of an idea of the possible, if they do possibly have CTE. Another thing that people and doctors and scientists are using is PET scans. PET scans can potentially detect tau, a buildup of tau in the brain, which is a major sign of CTE. However, tau is also a huge part of other diseases such as Alzheimer's. And due to not being able to understand the differences between Alzheimer's and CTE tau buildup, it is kind of hard to differentiate. And even though they are completely different diseases, they appear the same under these types of scans. This very far right column or left for you guys, is the control brains. This column is individuals who have Alzheimer's. And these are all individuals who had brain injuries and were suspected of having CTE. I am not someone who understands these things, and I have never really studied or been taught how to read these. But for me, they all kind of look the same. And even though there are tau buildup with the different colors you can kind of see, they are still very similar. And so maybe scientists and researchers do know how to read them more than I do, but they don't understand it enough to be able to say whether or not someone has CTE. One thing that I started researching was blood-based biomarkers. These have become a new thing in research of either cancer or, I don't know, I think they're also using it for diabetes and other such diseases. And it is a lot more affordable than scans or these really intense behavioral assessments, and they are a lot quicker and more efficient. So when someone gets brain damage, there are certain proteins and immune system like cytokines and just other things that can become increased when an individual has brain damage or a weird immune response. So some of these are the glial fibrillary acidic proteins, which are a sign of inflammation in the brain. Tau, as earlier mentioned, is a key part of CTE. And then these are also a buildup of show a buildup of tau tangles and kind of broken neurons inside the brain. So when people get their blood drawn, these certain proteins can be tested for, and doctors and scientists can detect if their levels are increased, which is a sign that these issues are occurring, which is also a sign of CTE. However, these proteins and cytokines are also associated with other brain diseases, and since they can't find the differences yet, they can't really say whether or not it's CTE or something else. However, I'm hopeful that soon they will be able to detect the differences between CTE and these other diseases, and most likely they'll even be able to find a specific marker that is specific to only CTE. So, even though people aren't able to detect it, they are still learning to function with it, and hopefully in the near future they will be able to be diagnosed with CTE and then be able to find treatment for themselves and their loved ones. Thank you.